All right, so now that we've kind of given an overview of the structure and functionality of the server components, let's see how they're actually implemented. And we're going to, of course, focus on the controller and service very quickly, but we're really going to focus most of our time on the concurrent flux and parallel flux strategies, because that's the stuff that does really interesting things. And, of course, you can find this in this GitHub repository, in the EX2 project, in WebFlux, in my Live Lessons GitHub repository. Speaking of which, this is the project, and we're going to come over here and look at the server. So let's take a real quick look at the server application. This application is using traditional web Flux stuff, where the actual server engine has a pool of threads. We're not, in this particular case, we're not using Java virtual threads. We're just using what comes out of the box with WebFlux, which has about as many threads as there are underlying cores on the machine. But because everything's done asynchronously, that's perfectly fine. So nothing really fancy about the main entry point into this application. Here's the controller itself. And we'll see that the controller has a couple of things. It's got an application context, which we probably don't really need in this case because we're not using Eureka. We also auto-wire the service, as we always do. And then the implementations, as we talked about before, very straightforward. They just go ahead and forward to the service, passing along the strategy. And this is that particular content type that says that this method, this endpoint handler method, consumes the application new line defined JSON, and that's necessary in order for the flux to work. If you don't do this, you get really weird runtime errors because Spring is like, what the heck are you sending me? I don't know how to deal with this. It doesn't look like a format that I expect. Here's the service implementation itself. As you can see, it's got this array of strategies, which there are different ways to do this. This isn't the only way to do it. It's pretty clever, but it does require the client to follow the same protocol, where the 0th strategy is the concurrent flux strategy and the first strategy is the parallel flux strategy. If you screw things up, then you're going to get weird results. You might not actually use something quite like this in production systems, but it's good enough for testing. So here's checkIfPrime. It just forwards to the checkIfPrime method. Kind of boring, so I'm not going to spend much time on that. Here's the more interesting one. It forwards to the appropriate implementation strategy that will either use concurrent fluxes with flat map concurrency idiom or parallel fluxes. Here's the abstract strategy. We looked at this before. You can see it's got two signatures, one with a default implementation, and the other one is going to use the forwarding to the implementation. So let's take a look at the implementation. Speaking of implementations, so here's the one that uses the concurrent mechanism in Project Reactor that's based on the flat map concurrency idiom. And you can see what it does. It's kind of fun. It takes the flux of integers as a parameter. And because we're already a flux, we don't have to do anything like flux from iterable, which is what we'd have to do if we had a list. We just say, hey, you're a flux. Thank you very much. As the data shows up from the client, thank you very much. I'm going to go ahead and take each of those prime candidates. And for each prime candidate in the prime candidate's flux, I'm going to go ahead and use the flat map concurrency idiom, which says take each item and then check to see if it's prime and do it in the scheduler's thread pool. So that's how you read this. And at first it looks a little bit weird because there's this couple extra moving parts and you're flat mapping your way through the prime candidate's flux, and for each prime candidate you're doing this somewhat mystical looking code. But once you get the hang of it, it's pretty idiomatic and pretty clear. So those things will be computed running in different threads, and they will send the results back to the client as they work along. And as they come back to the client can take them and then process them as they come back. It doesn't have to wait for them all to show up before it processes them. So that's kind of cool. So that's the flat map concurrency idiom way of doing things. Here is the parallel flux strategy. Looks very similar. But here's the difference. The checkIfPrime flux method in the parallel flux implementation uses, surprise, surprise, a parallel flux. So this also is pretty cool. It takes the prime candidates as they show up from the client, and it's going to turn that into a parallel flux, and it's going to run all the computations in the parallel scheduler thread pool. You have to do both of these things. This one says make the flux a parallel flux, and we could put a number in here that would be the number of threads, the degree of parallelism. By default, it uses the number of cores, which is what we want. And then you have to say run it on this scheduler. They don't combine those two things. I suppose they could, but they separated them into two different methods. Then what we do is we're basically saying for each of these prime candidates, now that we're a parallel flux, use the parallel flux map method and call the isPrime method on each of those things that flows through in parallel. So those will all run in different threads in the pool. And then when we're all done with this stuff, we convert the parallel flux back to a flux so that the results can come back to the client as a flux, because there's no need to pass it back as a parallel flux. I haven't actually tried that. I'm not sure if you can pass parallel fluxes in WebFlux. I think you have to limit yourself to fluxes, but that's fine. This works perfectly well. So that's the parallel flux version. For this particular application, it's really not that much different between the flat map concurrency idiom and the parallel flux version. In fact, you could make the argument that there's actually a tiny bit more ceremony in this parallel flux version, mostly because we have to say .parallel, .run on, and .sequential. So arguably, that might be a little bit more complicated than the idiom here, which has some fewer calls to make. But your mileage may vary, and really, the interesting question is which one runs faster. So we'll talk about that later. A couple things to note over here. We have the application properties file, which just says I'm the PrimeCheck app, and this is the port number that I listen on for incoming requests from the client.